All right, class, this video is going to cover two things here. The component form when given direction and distance. So how to find the component form of a vector when given the direction and distance. And then the other thing this is going to find is how to add vectors. Okay, adding vectors in component form is fairly easy. I'll show you that. I'll add vectors in standard form, again, fairly easy. But adding vectors that when you're given the direction and magnitude of two vectors and adding them, that's a little more difficult. That will be like problems you're going to see in 85 to 86. Okay? All right, so let's get started here. First thing, so here you're given a vector at 30 degrees. Remember, vectors, the direction is always taken from the x-axis. It's at 30 degrees and has a magnitude of 10. Okay, we're going to find the component form. Well, if you remember, component form is just the x distance, comma, the y distance. So if I draw this vector out like this, here's my x distance, here's my y distance. Component form is the x distance, comma, the y distance. So we've done trigonometry. We've solved for x in a right triangle when given the hypotenuse before. Okay, and when we know the angle of 30 degrees. Okay, so how do we find x? Well, x is the adjacent side, and we know the hypotenuse. So to find x, I'm going to use cosine of 30 degrees. That's going to equal x over 10. So to figure out what x is, I'm going to multiply both sides by 10. So 10 cosine of 30 equals x. Cosine of 30 degrees. You have your sheet, so you can use your sheet. Cosine of 30 degrees, square root of 3 over 2. So this is going to be 10 times the square root of 3 over 2. In this case, we're going to get an x value of 5 square roots of 3. Right? Because 10 divided by 2 is 5. Or if you are asked to find a rounded number, round to say 1 or 2 decimal places, 10 cosine of 30, you end up with about 8.66, comma, and then the y. So to figure out the y here, okay, that's the opposite side. So SOHCAHTOA, I know I'm looking for the opposite. I know the hypotenuse, and again I have the angle. So to find this opposite side, it's going to be cosine 30 equals y over 10. Multiply both sides by 10. So it's 10, not cosine. Sorry, it's opposite over hypotenuse. That's clearly sine, right? So hopefully you caught my mistake. So it's 10 sine of 30. Well, sine of 30, that's 1/2. So 10 times 1/2, y equals 5. Okay? So so here's your vector. If you're given a vector at 30 degrees with a magnitude of 10, this would be your rounded answer for your vector. So what's the general formula? Okay, this is the general formula that's going to work every time. If you're given magnitude and direction, to find the component form, okay, if given magnitude and direction, to change to component form, it's going to be the magnitude. Let's say it's vector u. It's going to be the magnitude of u times the cosine of the angle, comma, the magnitude of u times the sine of the angle. Okay? This will be the component form. This will be how to find the component form when you're given a magnitude and a direction. Okay? All right, next part. How do you add two vectors? Well, this isn't too hard when they're both in component form. Okay, adding u plus v, it's just, or v plus u, however you want to say it, it's just going to be 3 plus 1 and 4 plus 5. Not too hard. If it's in standard form, this would be 3i plus 4j. This would be I plus 5j. Okay? So 3 plus 1, this would be 4i plus 4 plus 5, 5j. So adding vectors, this is u plus b. Sorry, handwriting's getting bad. Adding vectors when they're in component form is really easy, okay? Or standard form. You just add like terms in standard form, you just add the x's, you just add the y's, okay? But what about if they give you two vectors in these forms, okay? So they just gave us the direction of each and the magnitude of each. Well, the first thing you're going to want to do is turn these two vectors to component form, because adding vectors in component form is easy. So to add these two vectors, I'm going to turn them to component form. So to turn this one to component form, it'd be 10 cosine of the angle, comma, 10 sine of the angle. All right? This one, okay, to turn to component form is going to be, the magnitude is 30, so 30 cosine of the angle and 30 sine of the angle. Okay? So these values are all on our sheet, right? We have cosine of 30, cosine of 60, sine of 30, sine of 60, they're all on our sheet. So we can just do this problem that way. 10 cosine of 30, this is, if you notice, this is the same problem we did on the other page, where we get 5 square roots of 3, because cosine of 30 is the square root of 3 over 2. So 10 times the square root of 3 over 2, you get 5 square roots of 3. Sine of 30 is 1/2. So 10 times a half is 5. Okay. Cosine of 60, well, that's a half. So 30 cosine of 60. So this would be 15, comma. And then the sine of 60 is also the square root of 3 over 2. So I get 30 times the square root of 3 over 2, which would be 15 square roots of 3, right? So now adding these two vectors, okay? So you can't add these, they're not like terms, but in your answer you could put 15 plus 5 square roots of 3, add these two together, they're not like terms again, so it's going to be 5 plus 15 square roots of 3, okay? If the problem just asks for a rounded answer, you can do this all on your calculator. You can put this right into your calculator, add these two up, okay? So it would be 10 cosine of 30, 30 cosine of 60. So 10 cosine 30 plus 30 cosine 60. Okay, so that would be my x component, 23.66. To get my y component, okay, I'm just going to add 10 sine of 30 plus 30 sine of 60. Oops. If you notice here, I didn't put the parentheses in properly. And there we go. So we just added those two vectors, 23.66, 30.98. So our answer is 23.66, 30.98. Now, just a little addition to this. What does it mean to add two vectors? So that first vector was 10 at 30 degrees, 10 units long. The second vector was 60 degrees, 60 degrees, but it was 30 units long. Right? So what does it mean to add these two vectors? Well, first, maybe we should talk about what a vector is. A vector is a force. Okay? A vector can represent wind blowing in a certain direction. It can represent gravity. It can represent someone pushing something else. Vectors can be moved around. So I can move this vector anywhere I want in space. Normally, you have them start at the origin, if they're just their own vectors. But if, say, you had a bridge, okay? So you built a bridge, right? You could have a car going over the bridge, and the weight of the, okay? And the weight of the car, I'll just go with the wheels, would be represented by two vectors, one on each of the wheels. Or a single vector, more than likely, from its center of mass. Okay? So it would be a force vector going straight down. Now that vector is putting a force on this bridge. Okay? And that it's going to be spread out because that's how the bridge is built. But you have to figure out, if you get into engineering at a high level, you're going to have to figure out how to do a force diagram and figure out if that bridge is going to be capable of handling certain forces. Well, anyways, back to what we're doing. We're just going to add these two vectors together. Okay? So here's how you add vectors. You take the vector right here, and you add this vector, and you move it right so that its tail is on the tip of this one. Now off my screen a little bit here. Not letting me slide down. There we go. Okay, so I have this vector up here. This is getting a little bit goofy. We'll kind of erase some of this stuff here. But now we came up with a new vector. The new vector starts here and goes to there. That's if I add this vector, call it u, and this vector, call it v. Okay? This is the mathematical result. This would be the graphical result. Okay? The tip to the tail of the other vector. Okay, so when it shows you to, tells you in the assignment to show what vectors look like when you add them, that's how to do it. Okay, hope this helps.